484. Every 60 units it's a second. So 484 is 8 seconds. 8 seconds to fill the screen with asterisks. Now I've added and modified some line of code in order to remove the computation of the address of the video RAM from the poke command. (343), that is less than 6 seconds. We had a 40% of improvement with few modifications. Now I'm going to use the print command instead of the poke to draw the asterisks. Here is the print inside the 4 cycle. (66). This is a huge improvement, just 1.1 seconds. Now we'll check the execution time for the same program written in assembly. The last program in BASIC used the print command. Now we are going to use the print subroutine in the assembly. This is the print subroutine. The program starts at memory address 1400 in hex that corresponds to page 20 of the memory. This simple program seems quite long because more than half of the code is required to compute the execution time and print it on the screen. (9). We improved from 66 to 9 using the print subroutine. Now the program will be modified, removing the print subroutine and storing the asterisk value inside the video RAM, similarly to what we did in BASIC with the poke command. The program starts at memory address 1500 in X that corresponds to page 21 of the memory. In this way, it doesn't overlap with the previous program. (0). This is very fast, about 1 centesimal of a second. It's a lot faster compared to the print subroutine. A trained eye can notice the speed difference between the two programs. This is the print subroutine. 9. And this is writing the asterisks in the video RAM. We repeat the same for the TheC64, just for the faster basic program and for the faster assembly program. $150. That is 2.5 seconds. Now the assembly. Zero. Also for the TheC64. Okay, so we measure that the assembly is faster than basic. Sometimes it's just 10 times faster or less, but sometimes it's more than 100 times faster.